Hello students, today we will go to discuss about Huffman coding. In the last class we have discussed about the Shannon coding. So another type of source coding is Huffman coding. So what are the different things about Huffman coding that we will study today? So what are the takeaways of your class? You will understand the algorithm of Huffman code and you can construct the Huffman code from this class. So what is Huffman coding? It is basically a prefix code as we have discussed for Shannon codes also. And obviously it is one of the best possible source codes because it has the lowest possible average code word length. So as it is having the lowest possible average code word length, so we call it an optimal code. And as it is an optimal code, obviously the efficiency which we have already considered in the Shannon code also, for this particular Huffman code, the efficiency is the highest. And as the efficiency is the highest, obviously the redundancy will be the lowest. So in other words, we call this code as minimum redundancy code or optimum code. So what are the steps involved for constructing in Huffman code? So first step is obviously you will have to arrange the source symbols in decreasing probability. So the source symbols will be given to you. The first thing is that take the most probable event, keep it on the top and the least probable event at the bottom. There might be some symbols which will have equal probabilities. So in those cases, you can place them in arbitrary order. That means you can place any of the symbol on the top or at the bottom. That is up to you. In the step 2, you will have to combine the symbols having the smallest probabilities. You will just add up the two symbols which are having the smallest probabilities. I will show you one example. Once you have added up the two probabilities with the lowest probabilities, obviously, then definitely the probability value will change. So you have to reorder the resultant probabilities, and this is called the first reduction or reduction 1 step. Then this process will be repeated until exactly 2 ordered probabilities are left. And when you are getting the final step, it is called the last reduction. So what is the step 3? After the reduction is completed, you will have to start the encoding. And the encoding will start obviously with the last reduction. Now, we will assign a 0 as a first digit for all source symbols associated with the first probability of last reduction. That means on the top, the value which is there of the probability, you will assign a 0 to that, and the bottom value you will assign a 1. Then what is the step 4? Step 4 is you have to go back to the previous reduction step because you have started with the last reduction. Once you have assigned zeros and ones to the last reduction, you will now have to go back to the previous reduction step. And again, you will have to repeat the same thing. That is, you will assign a 0 to the second and 0 to the top one of the second reduction and the 1 to the bottom one. And this step will be repeated until the first column is reached. So this is the algorithm how we can do the Huffman coding. So let us take one example here. Apply the Shannon code for a DMS. You know what is a DMS? DMS is obviously a discrete memory source with the following source symbols and given the probabilities of occurrence. Calculate its efficiency. So what are the source symbols? Source symbols are x1, x2, x3, x4, x5, x6, and x7. And what are the probabilities associated? That is 0.4, 0.2, 0.12, 0.08, 0.08. So you can see over here, x4, x5, x6, x7, they are having the same probability. So you can place them in any arbitrary order. For x4, x5 also, you can place x4 on top of x5 or the other way. Similarly for x6 and x7. So let us see how to do it. So here we can see the different probabilities are arranged here. Obviously, the source symbols are arranged in order of decreasing probability. So the highest probability is kept on the top and the lowest one at the bottom. So what was our second step? Second step was we will combine the two lowest probabilities. So these two are the lowest probabilities, 0.06 and 0.06. We are combining them. It becomes 0.12. So 0.12 is obviously higher than 0.08, 0.08. So that has to be reordered. So that is the first step of reduction. So what we have done, we have taken this 0.12, we have placed it below x3 because x3 is also 0.12. So as we have said, we could have ordered it above x3 also. So we have taken here in the below order. So that is what we have done. So after this step is completed, you find that these are the two lowest probabilities. So again, these two will be combined. When these two will be combined, it will become 0.16. 0.16 is obviously greater than 0.12. So it has to be reordered again, and that is called reduction 2. So this 0.16 is placed over here, and again it has been reordered. Again, the same thing, 0.12 and 0.12 is there as the two smallest probabilities. We again just take the summation of that, it becomes 0.24. So 0.24 is obviously higher than 0.2, so we again reorder it as in this way. So again, these two will be taken. This two has 0.36, 0.2 plus 0.16, that is 0.36. Obviously, 0.36 will be higher than 0.24, so it will again be reordered. Similarly, 0.36 and 0.24, when they are combined, that will become 0.6. So 0.6 is placed on top of 0.4. So once we have done this, this is completed. Now we have to start the coding process. And as we have said, we will start the coding process from the last reduction step. So this is the last reduction over here. And we will place a 0 on the top one and 1 on the bottom one. So this is 0 and this is 1. Now, where this 0 originates? That originates from these two. So for these two cases, again, the first digits will be 0, as 0 is being carried over here. And again, the same thing, that is the top one will be assigned a 0, bottom one will be assigned a 1. So it becomes 0, 0, it becomes 1, 0, 1. And this one, it has originated from here, so it will be simply 1, because it has no other values. This one is carried over here, this one is carried over here, this one is carried over here, this one is carried over here. So that means 0.4 has the code of only 1, because it is the highest probable event, so it is having the lowest number of bits. Similarly, this 0.36, it has been originated from these two. So first two bits obviously will be 0, 0 for these two. So you can see 0, 0 for these two, 0, 0 for this one also. And top one is assigned a 0, bottom one is assigned a 1. And this 0, 1 has originated from this, so 0, 1 is there. Now you can see this 0.2 has a value of 0, 0, 0. This has originated from this, so this will be 0, 0, 0, originated from this, originated from this. So ultimately 0.2, this x2 will have the code of 0, 0, 0. Similarly, this 0, 0, 1, this 0, 0, 1 has come from here, so this is also 0, 0, 1. And this one, that is 0, 1, 0.24, it has originated from these two. So the first two bits will be 0.01 over these two. And the top one is the 0, the bottom one is the 1. So like this, it will go on up to the last step. And in the last step, we can find that the codes are final codes, we can say. These are given by this. So this is the technique of the generation of the Huffman code. So our aim was to calculate the efficiency also. So what we have done, we have taken the average code length, and we know what is the formula for that. So we can use that formula. That is the probability, and this is the number of bits. So with the number of bits, with the probability, we have added up, some multiplied and added up, and it has become 2.48 bits. So this is the average code word length. And what is the entropy? The entropy is also, we know what is the formula for that. That is P. That is the probability with the log of the P probability. So that has given you the efficiency. The entropy. And this entropy is 2.43 bits per symbol. So what is the efficiency? Efficiency is obviously the entropy divided by the average code length. So that is 2.43 divided by 2.48. So it becomes 0.98. That means it is having the efficiency of 98%. So this is the technique of using Huffman code to calculate the efficiency. So you can see the efficiency is a very high efficiency because it's the optimal code, but still it is not 100%. So students, now you have to think over how or for which condition we can go for 100% coding efficiency, because it is possible. It is possible in Huffman code, but when, that you have to think about. You have to also think about how the Huffman codes can be utilized, or where the Huffman codes are being utilized in practical situation. These are the different things which you can study. Thank you. Thank you for participating in this lecture.